Yes, good morning and good evening, everyone. Today I'm talking about the decision tree algorithm for the regression data. In yesterday's class, we have seen the decision tree for the categorical data for the classification. But today, the input features are going to be a continuous data. The input features are regression data. How it will be able to categorize is the problem. I hope you will be able to understand that in yesterday's class, we took certain input features such as age, income, credit rating, student, all this, let's suppose. So this is the column which is age is the column. This is the column is the income is the column. This is the column where credit rating. This is the column is the student type. And another column is going to be the target label, which is going to be the target label. Laptop is buying or not. This is a column. Yesterday's problem here, age, income, credit rating or will be in the form of a categorical. Age is high age, middle age, youth, and income is high income, low income, small income, like that. Credit rating is, absolutely high, low. Everything, whatever the input data you had, that will be in the form of a strings or maybe a categorical form. And this is going to be the whether the buying a laptop or not, yes or no kind of thing. Now today we are looking at age will be a continuous data, which is regression data. Income is also regression data, and the credit rating is also regression data, and student type is going to be the yes or no, like that. Let us see now. I'll be show you how exactly the decision tree is able to classify regression data. Categorical data is different, regression data is different. Please, if you have any questions in this regard, this notice is very important. Let us take an example now. Firstly, import adequate libraries. So firstly, we required pandas. And from the scikit-learn, dot model selection, import training and test and split. Okay. From the scikit-learn, pre-processing, import label encoder. From the scikit-learn dot, we require a tree because we are working with a decision tree, right? Import decision tree regressor now, not a decision tree classifier. Yesterday we called the function model called as a decision tree classifier, but today we are going to call, there is a function is called decision tree regression. Okay, that's a difference. From the scikit-learn dot metrics, import accuracy, score, comma, confusion matrix, comma, classification summary. It's a report. Isn't it? Yeah. So these are the adequate libraries. I hope everybody knows when to apply what particular function, when to apply this model selection, when to apply this particular thing, when to apply this model, when to apply this all. You know very well at what stage they are required. Firstly, okay, let me execute these libraries has to be import, then we'll go ahead. Now, firstly, we'll take a static data, then we'll work with the Excel data. Okay. So now I'm creating a data. Create sample data, or else we can import the data. That's better, right? Import local data from the system onto cloud, because the collab is a cloud. Okay, now for that, import or else from the Google dot collab, import files. Okay, then uploaded is equal to files dot upload. This will be help you to import the data from the local system. Okay, I'm taking the data where my data is there. Okay, let us here. If you look at, there is a data is called as a by laptop is the data, which is the numerical data. Okay, yesterday we have seen that there is a data is a categorical data. Now I'm taking this particular data. Yeah. Okay, I have imported successfully. Next, we can go ahead, import. There is a input output is the one particular library where, let me take a data is equal to from the pandas read underscore CSV, because we wanted to read the CSV file, where IO dot bytes dot where uploaded of, there is a file is called as a bylaptop.csv. So this file is going to be import over here. So now absolutely, let us check whether the data has been loaded successfully or not. Yeah. So if you look at carefully in yesterday's class, age was categorical, income was categorical, credit rating was categorical, but now here the data is continuous in nature, which is called as a regression data. Data is continuous in nature, which is a regression data, continuous in nature. Please, I request everyone till here, you guys are clear? Are you guys are practicing or just listening the class? Maste, Rashekar, and Leela Sat is anyhow is never holding the laptop because he would. Yeah, yeah. Maste, are you practicing it
I'm
parallelly?
I'm listening.
Yes, sir.
Okay, okay. Let me complete then. Let me complete. Okay, okay.
Sir, that CSV file are you sharing or having in live, sir?
Who is this?
Leela Satish.
Satish Shapu.
ఈ ఫైల్ డ్రైవ్ లో పెట్టుండారా షేర్ చేస్తారా సార్ ఇప్పుడు
Just hold on. I'll share it. I'll share it. నేను కంటెంట్ లో షేర్ చేస్తున్నాను చూడు. డ్రైవ్ లో కూడా ఉంది, but I'm just sharing with you.
Yeah, typing and typing.
Yeah, I just shared just now in the content folder, and just hold on. Even I'll be keeping the drive also. I think this is the drive where I'll be keeping. Hold on. So I think due to some technical issue, I think it has been disconnected from my end. I'm sorry. I think, is that visible for you?
Yes.
Yeah, okay. So up to what extent I just executed the program? So I splitted the entire the data set as a training data set and testing data set and white train and white test. So the data will be created as a 4 parts because the algorithm would expect the similar kind of plugins or maybe inputs for that. Right? Yeah. So now so now we trying the decision tree now. We will be trying the decision tree regressive. Yeah. So now the model is equal to, there is a built-in function called as a decision tree regressor. Already have imported. Yes, decision tree regressor. So where we supposed to specify in the regressor that what is the max depth. So max underscore depth is the one particular parameter where we are going to specify. So depth of the tree is going to up to 4, and absolutely the random state is going to be the 42. Then obviously the model dot fit, where we are going to pass x underscore train comma y underscore train. So the model will be trained with this particular line of code. Then you can go ahead with yeah. y underscore predict is equal to model dot, and predict is the function where we are going to give it now x underscore test. So the values are going to be predictor you can able to check whether the data has been predicted or not based on the X underscore test. Now there will be two records have been taken. One sample will be categorized as a 0, another category will be 0 as 1. And now we can go ahead now. We'll be check the accuracy now. So if you want to generate or display confusion matrix, that confusion matrix is equal to, there is a confusion matrix is already we have taken as a built-in function for which you have to give y underscore test comma y underscore predict. Then you display the CM. You see the output now? Absolutely, this is the matrix. So absolutely diagonal 1 1 means absolutely it will be 100% is classified perfectly. Now if you want you can able to check the accuracy of the model, then absolutely accuracy is equal to accuracy score, where you can give y underscore test comma y underscore predict. Then you just try to be print accuracy. Comma accuracy. So 1.0 is nothing but 100% perfectly categorized a given testing data. Now if you look at the classification report, you can print classification report that absolutely classification report CR is equal to classification report for which is supposed to pass y underscore test comma y underscore predict, and then you print CR. So if you look at now, this is the complete report. So to classify the 0 100%, to classify the 1 also 100%, recall F1 measured support as a whole, accuracy of the given model will be 100%. It is able to predict for the given data set. I think clear everybody, right, till now?
Yes, sir.
Yes. Please, I'll be taking another example for a banking example. This is the general example. Yes, Maste, are you asking something?
No, sir. No.
Yeah. So we'll be taking another example now.
Is this my network problem? I'm not hearing you, sir. Oh, okay. Yeah, I'm not hearing. There is some kind of disconnection, something.
So let us take, another example for the same thing. Case study is that, loan is approved or rejected based on credit risk assessment. At a bank. So this particular case study is related to the bank. So there is a decision tree model. It is going to tell you that, whether your loan is approved or not based on your credit risk assessment, based on the certain factors. Like now I'll be taking now certain factors. Yeah, so am I not audible to you? Please can on.
So your voice is disconnecting in between, sir.
Can you confirm other people? Am I audible to you continuously properly?
No, sir. Same for me. I'm also missing your voice.
See, my internet is also be stable. Only today only it is like that, or every time we will have a same issue.
No, I
Only
think
today, sir.
yeah. Other days I didn't have any problem, but today it was getting disconnected somehow. I don't know.
I don't know. Even meeting is also disconnected suddenly. I think there was no problem with Wi-Fi also, but I'll do one thing. I'll be give you the task. Please, you try to be completed so that I'll be wind up the class. Now I'll be giving you the data now. So I'll be giving you a data set. The data set is going to have data is equal to. So I'm giving that, there will be a income of a particular person that you take, like that income can be in terms of dollars or something. You can take income can be 30, 60, 45, or maybe 80, 25, 90, 40. Randomly you can able to take, 70, 65, 45, 56, or else 96. Like randomly you can able to take the samples. I'm just showing you that, the data set where you will be having, apart from the income, there will be employment type, employment status, employment status. So where you can able to take it as employment status as 0, 1, 2, 3, maybe whether higher level status, or maybe lower level status, or maybe no job, like that, So something called as a 2, 2, 0, 1, 2, 0, 1, 2, 1, Like that, as many number of samples you have taken, like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 2, 2, 0, 1, 4, 5, 6, 7, 8, 9, 10, 11, 12. So totally 12 items are going to be included. And apart from this, and I'll be taking any existing loans are there or not. Existing loans is the another typical feature where you're supposed to take a maybe 0, 1, 2, 3, like 0, 1, 2, 3, like this kind of a status you can take. 0, 1, 2, 3. Zero, 1, 2, 3, 0, 1, 2, 3, 1, 4, 5, 6, 7, 8, 9, 10, 11, 4, 4, 4. Yeah, that's all. Already 12 we have included. Okay. And similarly, you can take a credit score. Credit score you can able to take where you can specify the credit score such as a 720, 650, 710, 750, 721, and 700. How many are specified? 4, 690, 705, and 704, 711, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 750, sorry, 752, 746. Yeah. So totally I took 12 entries related to credit score, and comes to there is another entry we can able to take a repayment history. Repayment history. That's another entry where we can able to take, there will be 0, 1, 2, like 0, comma 1, comma 2, 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 and 2, 2, 2. Otherwise, this is repayment history. Finally, the loan status is going to be approved. Like it's a Y, we can say loan status. That can be probably 1 is accepted, 0 will be rejected. 1, comma 0, 1, 1, comma 0, 1, comma 0, 1, comma 0, 1, comma 0. So 4, 4, 4. Yeah, that's all. So for this particular data set, I think I'm giving you this particular data set. It is available in the file, as well as you can take in a chart box that I'm giving. For this, I need to apply decision tree, and you have to be, it's a continuous data. Obviously, you can apply the decision tree classifier and tell me what is the model precision and model accuracy is going to classify this data, and how the loan is going to be approved or not. So please, I request everyone to complete this program as you followed the above approach. Please complete this particular program. So data set I have given, adequate libraries and adequate steps. Please take it as an assignment for you and try to complete this particular program. Are you clear, guys? I think it's a similar program, but the domain have been changed. Yeah, it's a credit risk assessment data bank. So I would like to conclude this session now. Please, you just complete this particular assignment. If possible, you can able to create many number of case studies and complete them accordingly, right? So I'm just seeing everybody is just listening the class and just doing whatever the experiment I'm explaining to you. You are not creating at least one project related to each particular algorithm. I think that's up to you whether it will be possible for you or not. Yeah. So now I'm concluding it now. Yes. Yeah. Thank you.
Thank you, sir.